Hi, everyone. Today, we will be presenting our interactive visualization, which focuses on global earthquake data. Earthquakes are highly catastrophic events and often lead to extensive damage. Therefore, earthquakes negatively impact communities across the world. So, it is essential to understand and investigate trends in earthquake data. As a result, we aimed to create a visualization that would display patterns in major global earthquakes throughout the past century. Our dataset is from the public Tableau data website, and all data points were derived from the United States Geological Survey. This visualization includes all recorded global earthquakes with a magnitude of 6 or greater from 1900 through 2009. Overall, there are 7,631 earthquakes in our dataset. We wrangled the data to filter the earthquake events into specific decades and continents based on longitude and latitude coordinates. Our visualization has two main components. First, we have an interactive line graph on the left-hand side, which displays decade on the x-axis and earthquake frequency on the y-axis. Each line represents a different global region, including Asia, Europe, Africa, Oceania, North America, South America, and Antarctica. A static legend is visible at the top of the line graph. In the legend, each global region is associated with a distinct color, which matches each line color. Furthermore, every dot is positioned based on total earthquake frequency value for each decade. If a user hovers over a dot, the entire continent line grows bigger. Also, the node you choose changes color to white. When a user hovers over a dot, a tooltip pops up with information about that decade. For example, when I hover over this point, we see the total number of earthquakes that occurred in Asia during this particular decade. Along with the frequency value, the tooltip includes the top 3 locations with the highest number of earthquakes. The second component of our visualization is the map on the right-hand side. Every major global earthquake is displayed as a red dot based on longitude and latitude coordinates. The default view includes the entire world. However, the user can freely zoom into the map and find individual earthquake events based on location. Also, a user can hover over any earthquake data point to display details about that particular event. Specifically, this tooltip feature tells the user the specific location, date, time, magnitude, and depth value of an earthquake. Hovering also changes the color of an earthquake event from red to green. Another feature of our visualization is interactivity between these two components, the line graph and the map. If a user clicks a point on the line graph, the earthquakes that occurred during that decade within the specified global region are highlighted on the map. Now the user can specifically visualize events from a particular time point. At this time, we have a few bugs in our code, so in this demo, when I click on a point on the line graph, the earthquake events for that decade disappear on the map. When I unselect a point on the line graph, the nodes reappear. We will be fixing this issue over the next few days, and we intend for the line graph to act as a checkbox filter for the map. Another thing we aim to work on before the deadline is the position of the tooltip in the line graph. We want to position the tooltip box at the point of interaction on the line graph, so when a user selects a point, the tooltip should pop up directly next to the point itself. Overall, this visualization is very interesting to explore. It is now clear that earthquake frequency has dramatically increased over the past 100 years, and this is a trend in every single global region. Many scientists have hypothesized that this increase in earthquake events can be attributed to climate change. Our interface provides evidence to further investigate this claim. Lastly, we can use this visualization as a resource to investigate earthquake trends, specific individual earthquake events, and potentially to predict future earthquake patterns. Thank you for listening, and we hope you enjoyed this presentation.